Hello? Hello?
Hi, how are you?
Good, how are you?
Pretty good.
We'll be starting in a few minutes. But you're the first person that entered the class, so let's wait for a few minutes, then we'll begin.
Okay.
How are you doing, Mr. Aaron?
I'm good, man. How are you?
Good. So I think we can begin. You can see my screen, Miss Ania and Miss Aaron.
Yeah.
Good. So on Monday, we completed measures of central tendency for ungrouped data. Today we do the measures of variation for ungrouped data. Then after that, we can now start looking at group data. So today and Friday, we'll be working on that. Yeah. So the measures of variation, we call them measures of variation because, excuse me, they explain, sorry, excuse me, we use them to describe how the individual values have strayed away from the mean. Like I was explaining in last lecture. So in a road where the speed limit is 45 miles an hour, so some cars might be going 50 miles an hour, some will be going 40 miles an hour, in which case the deviation is only 5 miles per hour. So those distances are not, the deviation is not much, so you may not be bothered by the cops. But when you are moving or driving something like in that kind of road, you're driving up to 60 miles an hour, then you attract the attention of both the cops and other motorists. So bottom line is that how far did the theta value stray away from the mean? That's what we use this as by measures to estimate. So they include the range, okay, the one that we'll be looking at, the range, the variance, standard deviation, and the coefficient of variation. So these are the main measures of variation that we'll be looking at. Let's start with the range. The range is the easiest one to calculate. The range is the simply put is just the maximum value minus the minimum value. That gives the range. So you subtract the minimum value from the maximum value. That will give you the range. Now for the variance, this requires more complicated formulas. Okay, to calculate the variance and the standard deviation. Once you get the variance sum, you can get the standard deviation, which is the one we usually use. So because variance, you square all the deviations, but the standard deviation will give you the square root of variance. So it's kind of a more conservative estimate of the variation or deviation from the mean. So we call it the standard deviation. So the square root of the variance will give you. So once you get the variance, you find the square root of the variance to give you the standard deviation. So now we use variance and standard deviation in many ways, in many places. For example, they can use as the barometer for measuring deviations from the given standard. A good example is now let's say that the management establishes a standard that we to be following, or maybe a goal. So how okay, let me narrow it down a little bit and to something like quality. You're making a product, let's say a soda. There's a quality standard you have to. You must say, okay, this standard, the quality should be, the test should measure within a certain range, or maybe the sugar content should be certain level. Let's say 5 ounces. For example, this drink here, this bottled water is 33.8 ounces. So let's assume that this is the soda you are making, and you said that the sugar content should be only 2 ounces. Now, of course, some bottle may have, some content may have 1.999 ounces or 2.0001 ounces. They're still good. But when you go to 3 ounces, see, the deviation will be too much. So we use it in quality control. So it can't deviate more than 1.999 ounces or 2.05 ounces within that range. So that's kind of a way of using this variance and standard deviation. Now, another example is this. If you have two PVC pipes, you know the pipe that we use for plumbing water. So the pipes, if they're too, if the distance, the width of the pipe are too not very close, they cannot fit. You know, that's another way you can use it. Now, the coefficient of variation, and this one we use this to comparing the degree of variation from one data set series to another. We use it more in the investment community. They can see, check how this stock changes when the other stocks change, you know. And how about standard of living? The standard of living in different cities can also, we can use coefficient of variation to check that. So the in the investment world, we can use the coefficient of variation to check the degree of volatility in a stock. So all these things they have use them basically in every day at higher level. Now let us see how to calculate them. I will do some of them today and then finish the rest on Friday. The first one we'll be looking at is the most students have come in. That's good. The first one we're looking at is the range. The range. So how do you estimate the range? Okay. Okay. So the range, like I told you, the formula is the maximum value and not the minimum value. I have it here already, so let me just copy it from here. The maximum data entry minus the minimum data entry. So it's the easiest to calculate among these measures of variation. Okay. Maximum entry versus minimum entry. Let's look at this example. It says a corporation hired 10 graduates, then the starting salaries for each of the graduates are shown. Find the range of the starting salary. So you can see the starting salaries in thousands of dollars. This person started with $41,000 per year. This person with $38,000 per year. this person with $39,000 per year, and so on and so forth. Find the range. So the range solution range the again the maximum data entry. Maximum here is 47, I believe. And minimum is I believe it's 37 here. So the range is 10,000, which is same as saying $10,000. So how do you interpret it? So the difference between the maximum salary, the salary paid to the highest earner in that company, and the lowest earner is $10,000. Okay. Explanation. The difference in the amount between the amount paid to the amounts paid to the highest earner earners and the lowest earners in the company or the affected company or organization is $10,000. Any question for me? Question?
No.
Yeah. Now, so this is a range. Like I say, this is the easiest to calculate. Now, let's look at the one that are more challenging, which is the variance and standard deviation. Remember, all these are for on-group data. We haven't got done with that for group data. So with that one will be doing next week. Deviation. Okay. Now, to be able to calculate this, we need to know the formula for them. Now, we have up to 3 different formulas for variance. And then, so like I said, stick to the one we are using, and it should be fine. Now, the variance formula, I'm going to use a shortcut formula for the variance, and I'll open a new book so it will allow us to write them down, write it down. I can transfer it here. So, variance will be okay. A variance, because we're looking at sample variance, it's gonna be S. It's gonna be S out the square to show that it's a variance. So it's S. Okay. Oh, yeah, I can see it. I can see it. So this is the variance right here. Okay. Equals. I'm put it summation of x squared. Now summation of x squared. So we have summation of x squared. Let me bring it down a little bit. Summation of x squared. Okay. All right, say x squared. Okay, squared minus summation of x squared. Okay, I think I missed something. So we have it in this form. Summation of x squared. All right, just the formula part. I'm trying to put it together. But I think I also missed something here. Okay, I got it. The summation of x squared. I got it now. Putting the formula together can be a little bit on a computer can be, but if I write it on the paper, x is much faster. Squared over n, okay, divided by n minus 1, n minus 1. So this is the formula for variance. With this formula, we can get the variance, and then the square root of the answer will give us the standard deviation. Okay. Okay, let us get the standard deviation formula. Then we can now solve the equation. Standard deviation, then we're using S since which is sample variance we have. So you have the square root of variance, the square root of the variance. That will give us the answer for the standard deviation. So I have it right here. The square root of variance was the standard deviation. Okay. So now we're ready to solve. Since now we have the formulas in. And like I said, if you know how, there's other formulas you can use. If you know how to use them, you're welcome to use them. So long as you know how to use them properly. Because if you use them the right way, your answers will be the same. So let us apply this to this question here. It says here that they make it a little bit big. Okay, it says the data below show how long in months an experimental paint lasts before fading. Excuse me. It says compute the variance and the standard deviation, and then explain your results. So the first thing you do, like I said, there are some books will say find the mean and subtract the deviation from the mean. That's another way of doing it. In their book, I think that's the way they use it in their book. So if you know how to use that one, fine. And as long as you use them well, you get the same result. But I'm going to show you the shortcut to this. So we're going to make a table of values. Okay. This is the table of values we're going to be using. Excuse me. So x number which represent the how long, that's number of months, and then x squared, which represents just the square of this x. So now if you look at the formula, you can see why we're using that method, because it said x squared, then x squared over n. In this case, we have n is how many of them that we have. So this should be our solution. Let me write it down. Solution. This is solution right here. So I'm gonna put this. Now x squared. So x is the first x is 35. Second x is 45. Third x is 30. Fourth x is 35. Fifth x is 40. Sixth one is 25. Okay. Okay. Now you get your totals. X squared. I gotta make it like a square. Okay, good. Now you square each of these numbers here. Let me arrange this very well so we can move from there. Good. You square each of them. Now That means 35, SQL means 35 squared. From our Desmos calculator, we know that, let's see if I can pull out Desmos from here. I think I can pull Desmos from here. Oh, excuse me, this is Zoom. Okay. Let me go and pull out Desmos calculator. Give me 1 minute. Let me pull it out. And then I can share it with you. Desmos. Okay. Desmos. Yep, good. Now, 35 square means 35 times 35. Or you can just write 35. This is square right there. Give me 1225. 1225. I'll go here and put 1225. Next is 45 squared. So I'm going to take it back to Desmos to get 45 squared. Okay, got this. 45 squared, 2025. So taking you back to the work 2025. 2025 for that. So following this method, I got the rest of them. 30 square is 900. 35 square, we got it already as 1225. 40 square, I got 1600. 25 square, I got 625. And when you add all of this in your calculator, I did it and I got some 600. There's a mistake I'm making here. This total should be here. I should be on the side. Anyway, I'm gonna have it here as I added this here. I got 210. So these are your sum of x and sum of x. This one is your sum of x. Let me write it down so you can see it. Sum of x is 210. I'll take you to the other workbook. Sum of x. Sum of x equals 210 and the sum of x squared. Okay. X squared is I got the total as some 600. Let me take you back so you can see what I mean by all this. To the our main workbook. Right here. Let me push this down so we can have more room. Okay. Good. You can see what we have here. That this part is sum of x, and this part answer here is sum of x squared. I remember the formula that it is sum of x squared minus sum of x squared over n minus 1. Now, what is our n? Okay, our n is how many numbers we have? 1, 2, 3, 4, 5, 6. It's 6. By the way, this is small n, not capital N. Now, with this, all we have to do now is to plug these values into this formula here, and we will get our variance. Then the answer we got from that, we now find the square root of that answer, we get our standard deviation. So let's do it. Let me write it down. We have the sum of x squared. So let me copy the formulas down, then we can plug them in, and then you can see how they work. I'll put the formulas here, and then I'll I'll write it down so I can put it, be able to put it on the formula form, put numbers in, and then we calculate it. The variance will be the sum of x squared, which is 7,600, minus sum of x squared, which is 210 squared. Know what I will show you in a few minutes. Divided by n, which is 6. Then everything divided by n minus 1, which is 6 minus 1. Now I'm going to put this in the formula form so you can see what I mean by this. Okay. We got this form. Variance S equals sum of x squared. We have 600 minus 210 squared. Again, 210 squared. Okay. Over n is 6 divided by 6 minus 1. See? When you simplify this, I've got this for some 600 minus. Now this part, let's do this part. 210 squared over 6. Let's do it in decimals. 210 squared over 6. I'll take it to decimals. I got this 210 squared, then divided by 6. Give me 7350. 7350. So like 7350. Over, now I have 6 minus 1, which is 5. See? Excuse me. Now, let us simplify this. Let me copy this so you can see this in your other. Excuse me. Let us just finish it here, then I'll copy it to that side once and for all. So now you have 7600 minus 7350 divided by 5. Write it down. 7600 minus 7350 divided by 5. So I'll take you to decimals. So have 7600 minus 7350 divided by 5. 50. 50. So the variance is 50. So I put it here and then copy it to the main workbook. 50. So this, you can see why I call this method a shortcut, because it give you the result right away. What is main work right here? So variance is right there. It's 50. Any question for me? Any question? Hello, class. Do you have questions for me?
No.
Okay, let's do the standard deviation. Standard deviation is simply means the square root of the variance, which is the square root of this answer here. So I'll take you to the workbook. Standard deviation. Standard deviation to be square root of variance, which is the square root of 50. So this we can get from the calculator. The square root of 50. I got it as square root of 50. 7.07. Okay, make sure 7.07. 7.07. Now, at this level, I don't require you to interpret the standard deviation, because it's to some extent it has a relative interpretation. So just know that standard deviation is this amount. But when it is high, it means high volatility. See? Any question on this one? Any question?
No.
Okay, so we have done variance. We have covered the range, how to get the range, and I'll show you how to get variance and standard deviation with this example. Now, when these examples, this particular one, variance and standard, when the amount is so long or so big, this will take you a long time to figure out. So that's why we also do it in Excel. I can show you how you can do it in Excel. Let us go to Excel, and with the same problem, then you can see how fast you can get the variance and standard deviation. So let me take you to Excel. Excel right here. I have the numbers in already. So the variance in this case would be variance. Let me type it in. Standard deviation. So these two values, Excel simplify the method of calculating them, so they have become easy. In this case, variance will be put equal sign times variance. Because you are dealing with sample, use variance var.s. Once you show that, double click on that, then to give you the variance for the sample. You highlight all this, and then close the parenthesis, and press the enter key. That will give you the variance right away. So you can see that we got the same 50 we got. Okay. Now standard deviation is equal STDEV. Now again, because you are dealing with a sample, you're going to use standard deviation for a sample, which is STDEV.S. Then highlight this. Then close the parenthesis and press the enter key. See? 7.07. So now it has too many decimal places, which you can reduce from here. Decreased. See? Okay, this one is increased. So decrease is this way. Okay. Any question for me? Okay. You can see the difference. Now, so if have a large data set, you might consider using this approach, variance and standard deviation. Let us, I think we're almost done. Next thing we look at is the coefficient of variation. Yeah, coefficient of variation here. Now, the coefficient of variation, like I said, we use it to measure comparing degree of variation from one data set to another. For example, somebody who moved from Baltimore to New York City, Baltimore City to New York City. The person who moved, if somebody earning 50,000 a year in Baltimore and living in Baltimore City, and somebody making $80,000 a year and living in New York City, they're almost the same thing, because if you compare the standard of living, for example, when it comes to housing, we have higher housing costs in New York City than in Baltimore City. So the difference in salary might be here, in terms of number, numerical difference can be there, but the real purchasing power of the money may still be the same. And we use this value, coefficient of variation, to calculate that, this difference, or compare the variation of the two. So let us round up with an example on that. It says the mean number of pounds sales over 3-month period is 87, and the standard deviation is 5. The mean amount of commission is 5,225, and the standard deviation is 773. So the commission is not, they're not too related, but they're quite close because you make commission by through sales. So compare the variation of the two and explain your results. Okay, let us start work. Solution. Have excuse me, for cars. I like this kind of thing. I like to put them in a table form, but that will save a lot of time. For cars, and then we have. So let me make it in form of a table. Anyway, it doesn't really matter. I'm gonna make it this way. Cars, then sales. Put it this way. For cars, we have say sales, the mean number of sales. Mean, then standard deviation. Now it says the mean number of car sales is 87, and the standard deviation is 5. So you have mean is 7, and the standard deviation is 5. And for commission, the mean of the commission is 5,225, and the commission is 773. So let's compare the variation. The formula for it is the standard deviation over over the mean times 100%. So let me write it down so you can take you to this workbook. The coefficient of variation. The formula is the standard deviation over mean. Standard deviation divided by mean. I'm going to use X bar for mean. Okay. We have right here. Okay. Over mean times 100. That's the formula right there. Okay. Right, that's the formula right there. Standard deviation divided by mean times 100. So for car, excuse me. For car sales, have that the coefficient of variation CV equals we have standard deviation is 5/87 times 100. Okay, we can get it from decimals right away. 5/87 times 100. 5/87 Okay, times 100. The 5.75%. Which is 5.75%. Now let us do the same thing for cells and see which one varies more. Yeah, for car cells, the coefficient of variation will be equal to standard deviation over mean, is B 773 divided by the mean of 5225. Yeah, times 100%. Yes, I have to write this one down. I can carry it on my head. So I have 773, but 5225 times 100. Okay. Taking you back to this move where we can figure this out. I have what is it right here? Okay. Have it. 773 divided by 5225. So I got 14.79%. Okay. Now 14.979%. Okay. I have 14.79%. So you can see that this coefficient for car cells is larger. So that means it varies more than the cells. So if you make a small amount of cell, you still can make a bigger commission, something like that. Any question before we leave?
No, thank you.
Welcome. So I will see you guys on Friday.
Bye. Have a good day.
Have a good one.
You too. Bye-bye.